Hello, Applied 30. Today we're going to be looking at graphing to solve systems of linear inequalities. The last lesson we looked at dealing with systems, and the lesson before that we looked at dealing with inequalities. Now, not only putting them together, we're going to be solving actual problems. To start, we're going to work with what I call the boat problem. So the boat problem goes like this. A company north of Winnipeg makes two types of boats on different assembly lines. They make aluminum fishing boats, and they make fiberglass fishing boats. When both assembly lines are running at full capacity, a maximum of 20 boats can be made in a single day. The demand for fiberglass boats is greater than the demand for aluminum boats, so the company makes at least 5 more fiberglass boats than aluminum boats each day. My question is, what combination of boats should the company make each day? Well, to solve that, we're going to be using our handy dandy Desmos. And the difficult part is taking the information from the problem and applying them to inequalities. For example, we were told that when both assembly lines are running at full capacity, a maximum of 20 boats can be made in a day. Well, let's say that X represents our aluminum boats, and let's say that Y represents our fiberglass boats. Well, if a maximum that they can make is 20, X plus Y must be less than or equal to 20 boats. Then we have to look at the other parameter they told us, and that's regarding the demand for fiberglass boats. Fiberglass boats are more in demand than aluminum boats, so the company makes at least 5 more of those every single day. So that equation ends up becoming X, which represents our aluminum boats, plus 5 is less than or equal to our aluminum boats. And those are our two inequalities. Now, there's two things to watch out for on the graph. As you can see, the lines are solid, and the lines look like they go less than 0 in all directions. We know you can't have a less than 0 boat. There's no such thing as a negative boat. So you need to put the parameters in if you know how. If you haven't practiced much with Desmos yet, that's okay. I'm going to post some of the restrictions here so you can see what they look like. So for the yellow part of the graph, restriction looks like this. And for the green part of the graph, it ends up actually being the same restriction because you can't have less than 0 of either boat. Now, what the two inequalities are telling us in a graph is at any point in this region where both the yellow and the green graph overlap, that will be a valid solution to our problem. Now let's take a look into making sense of the problem. First thing we can do is let's label our axes. I'm going to call on the x-axis my aluminum boats. And I'm going to call my y-axis my fiberglass boats. And we're going to pick a point somewhere on this graph. Ideally, we want a point in this region where both the yellow and the green are overlapping. So let's make a red dot there. So we have to pick an x value that fits in this gap here. I could pick any x value. So I'm going to pick, say, 3, for example. And the corresponding y value at 3, well, there's a ton of them, right? One day I could make 10 fiberglass boats. Fits into the region there. On another day, I could make 15. And on another day, I could make 17 of those boats. Notice though, if I go a little bit beyond 17, let's say I made 25, 25 is too much. Let's do 22. I'm still within one inequality, but I'm not within both inequalities. So this is no longer a valid solution. Now, one more thing to watch out for. This is an example of a discrete solution set. Not all real numbers are valid. For example, I could, based on what I've shown you on the graph so far, choose 2.5 for my x value, and choose 17.5 for my y value, and it still fits within our shaded region. But here's a problem. You cannot manufacture 2.5 aluminum boats, and you cannot manufacture 17.5 fiberglass boats. This solution set is discrete, and unfortunately I don't know how to identify that on a Desmos, so you need to make a note of that, either on your screenshots or somewhere in your note, that this is an example where the solution set is an element of whole numbers. Whole numbers are any positive integer, including 0. Okay? So that's all I really wanted to show you for now. The next thing that you can work on is quite a bit of practice, significantly more practice than we had previously. So I'll post those up for you to try out. And as always, if you have any questions that come up, you're more than welcome to give me a shout, and we'll take a look at those when we get a chance. All right, take care.